So, hello, my dear students. I hope you're all doing well. My name is Benathan Paton, and I welcome you all to the channel Classroom, where we learn together. So, I welcome you all back. And today, my dear students, we are starting a brand new chapter, chapter 9. The name of the chapter is Light, Reflection, and Refraction. If your subject teacher has already taken in the classroom, then it'll be very easy for you. It'll be like a revision for you if you watch this video. And if your teacher has not taken it, then well, you can learn so much by watching this video. So in today's video, I will be covering the introduction, and we will be talking about light, the definition of light, then reflection of light, the laws of reflection, and then the types of mirror, and some important terminologies associated with mirrors. Okay, and finally we'll wrap up with the nature of the mirror. So it's going to be a little lengthy video, but then, well, the lengthier the video, if you understand, the better it is, not. So once you learn, okay, you should try to learn more. Okay, a little knowledge is dangerous, they say. So we should always gather lots of knowledge. Okay, so let's start a class. Let me directly go to the lesson and let's get on with the class. Okay, so like always, at the very beginning of the class, I always encourage you all to grab a notebook, a pen, or a pencil, and to take down the notes. Okay, let these classroom notes serve as additional notes for you, so that it'll help you clear your doubts better, and it'll help you score better in your exam. It can be a class test, it can be a weekly test, or it can be your exam. But then let these notes also serve as a let them serve you, let them help you. It's not let them help you. Okay, so you should learn from every possible means, and then we are living in the 21st century, and then we learn a lot from YouTube. Okay, and even me being a teacher, I'm also learning this platform. So because in the future, we are becoming digital. Okay, and even me, I never thought that I will be doing this, but then I am also moving at par with the changing generation. So I'm also getting used to it. So this is me leaving my digital footprint in this 21st century. Okay, all right. So so that's what I have to say about the changing environment and the changing generation we are living in. Okay, and in the future, things are going to change a lot. So we can only we don't know. Okay, I don't know for sure. Okay, I don't know for sure, but then it's filled with excitement. Are you excited? We should all be excited. Okay, so the future is very bright and very interesting. So we have to be excited. Okay, we have to move forward with positive energy. So enough of that. Okay, enough of that motivation, which is very, very important. Now let's start with the class. So let's first define light. What is light? Okay, so are you ready with your notebook, with your pen, pencil? All right, so let's start. So let's first define what is light. So define light. Define light. So what is the definition of light? Light has got a very simple definition. The definition of light is a form of energy which enables us to see. That's it. Okay, that's the definition of light. So light is a form of energy which enables us to see. So light is a form of energy which enables us to see. It's a very simple definition. Okay, now there are different forms of energy. We have got heat energy, we have got sound energy, we have got kinetic energy, potential energy, okay, electrical energy. There are different forms of energy. Among them, light is also one of the forms of energy, and this light, it helps us to see. Okay, so this is the definition of light which you can write. Now let's talk a little bit about since this class is also the introduction class to the topic, so let me give you some other, let us try to build a good base today being the first class. So let's talk on how do we see. Okay, so how am I seeing? How are you seeing me? So how do we see in general? So my dear students, we see because of reflection. Okay, we see because of reflection of light. So the sun is out, and the sun is out, and from the sun rays fall down on the object. So we have an object. Okay, we have an object. So this is the object. So the sun rays, it falls down on this object. It can be anything. It can be a tree, it can be a stone, it can be a car, it can be a house. So the sun rays falls down on this object. So let me just make sure that it touches this. And then after it falls on the object, what happens to the sun rays? The light, it gets reflected back. So this ray of light, it gets reflected. Okay, it gets reflected. And then this ray of light, let me draw an eye here. Okay, so this ray of light is what enters our eye. Okay, I'm very bad in drawing, but I hope you got my point, that this ray of light is what enters our eye. Okay, so with this we're able to see. So we are able to see because of the reflected rays which are entering from the object. Okay, from the object. So light first falls on the object, light first falls on this marker, then this marker reflects back the light which fell upon it, and then the reflected rays, they enter my eye, and that's how I'm able to see this marker. All right, so I hope you understood now how we see. Okay, so we see because of reflection of light. Now, not only seeing, but because of reflection of light, we are also able to see colors. Okay, we're able to see colors. So even seeing colors is possible because of reflection of light. So how do we see colors? See, now you know that light, okay, light comes from the sun. If I ask you what is the color of this light, then from your past knowledge in class 8 and class 7, your science teacher must have told you that the color of light is considered to be white. Okay, so the color of sunlight is considered to be white. But you know that if this ray of light is made to fall on a prism, prism, if a ray of light is made to fall in a prism, what happens? It splits into 7 colors, isn't it? 1, 2, 3, 4, 5, 6, 7. It falls into a band. It splits into a band of 7 colors, which we know as Vibgor. Okay, so V I B G Y O R. This is the spectrum of the colors which we get to see when we make a ray of light fall on a prism. Okay, so this is the 7 colors which makes up the white light. Together they make the white light. All right, so white light is made up of these 7 colors. Okay, violet, indigo, blue, green, yellow, orange, and red. So these are the 7 colors. Now how do we see color? So here, let me show you. I have a red duster. So this is a red duster. So you know the color is red. I'm not saying blue, nor am I saying green. This is a red duster. It is red to you and it is red to me. Okay, so how is it that this is red? This is red because of reflection of light again. So the phenomenon here is that this plastic part, this has absorbed every other color which fell upon him. It has absorbed violet, indigo, blue, green, yellow, orange. It has absorbed all the 6 colors, and then now what it's doing is it's reflecting. Okay, it has absorbed every color, and then it is reflecting what? It is reflecting red. So it's reflecting red, so this appears to be red in color. So this is red in color because it has absorbed every color and then it's reflecting red. Okay, then this is a yellow duster. So it is yellow because, let's use the same principle. It is yellow because it has, well, light falls on this object first, and then it absorbs all the color, and then it reflects back what color? What is the color here? Yellow, isn't it? So it has absorbed all the color and then it reflects back yellow. Okay, similarly red also, it absorbs all the color and then finally it reflects back which color? It reflects back red in color. So this is how objects get color. All right, so 2 dusters. One is red. It is red because it reflects back red. It is yellow because it reflects yellow. What has happened to the other colors? The other colors it has absorbed. So for this, okay, it has absorbed all the other colors and then it is reflecting red. For this, it is absorbing all the other colors and it's reflecting which color? Yes, yellow. Okay, so remember, objects get the colors because of reflection of light, and then you and I were able to see because of reflection of light. Easy, no? Okay, so some important concepts before we dive deep into the lesson, and then since we are talking some basics, let's also talk about the nature of light. So what is the nature of light? The nature of light. So what is the nature of light? Now, it has been, okay, the nature of light has been very complex. So throughout time, many scientists have struggled with it. And then there has been a lot of debates, and then a lot of experiments were done. And finally, now we have an accepted, nature of light. So it's also mentioned in your textbook, NCRT textbook. Everything we're discussing is from the syllabus. It's part of the syllabus only. So the nature of light, which is mentioned in your textbook, is light exhibits wave nature with particle light exhibits wave nature with particle like properties. Okay, that is the nature of light. So nature of light in your textbook, which is mentioned, is wave nature. Light exhibits wave nature with particle like properties. So this is the nature of light. So light has got dual nature. So we can say that light has got dual nature. Dual means two. Okay, dual means two. What are the two nature of light? Light exhibits wave nature. It has got a wave nature. Okay, it has got a wave nature. So one nature is that of a wave. So wave. And the other one is that of a particle. The other one is that of a particle. So remember this, that if anybody asks you, what is the nature of light? Tell them that light has got dual nature. One nature of it is wave, and the other nature is that of a particle. Now, for class 10, our topics are mostly on this particle nature. Okay, for the wave nature, I don't think we are going to discuss on wave nature, but you'll be studying about this in your higher classes, class 11, 12. Okay, now this is useful. The wave nature of light is useful to explain phenomena like diffraction, diffraction, then polarization. Okay, this phenomenon can be explained with the help of wave nature of light. For particle nature, we are going to study this. So our syllabus, the name of our lesson itself, reflection and refraction. To understand reflection and refraction, we need to study through the particle nature of light. So for to understand reflection and refraction, we will be requiring the particle nature of light. So this is useful in understanding reflection and refraction. All right, so remember, light has got dual nature. It has got wave nature as well as particle like nature. Okay, so this is the introduction, which is important for you to know. So definition of light, then how we see objects, and how objects get a color, then the nature of light, wave nature with particle like properties. Okay, so let me erase this, and then let's go to the next topic. So now we will discuss reflection of light. Let's go into the lesson and discuss reflection of light. All right, let me use this cloth also. Next topic, reflection of light. Reflection of light. REFLECTION. Reflection of light. Reflection of light. So what is reflection of light? Who will tell me what is reflection of light? Anyone? Raise your hand. All right, good. So reflection of light. So let's first write down the definition of reflection of light. The definition goes: the bouncing back of light, the bouncing back of light when light hits a polished surface like mirror, like a mirror, let's put a comma here, like a mirror, is called reflection of light. It's called reflection of light. So this is the definition of light. The bouncing back of light when light hits a polished surface. Remember, class, it has to be a polished surface. Best example of a polished surface is that of a mirror. We are all familiar with mirror, isn't it? So a mirror is an example of a polished surface. Okay. So let me wipe this on. Maybe I have refilled this with a lot of ink. There's a excess flow of ink happening here. I have to be careful. So we all know what is a mirror. So a mirror is a best example of a polished surface. Okay. So the bouncing back of light when light hits a polished surface like a mirror is called reflection of light. Okay. So let me wipe this out. Now, so let's understand reflection properly. So as per the definition, we will be needing a polished surface. So let me draw this. Let's say this is a surface. Is it straight? Okay. So this is a polished surface. Let me change my marker. Too much ink, it leads to leakage. It's difficult. It's not easy to write also. All right. So this is a polished surface. So the polished surface. So this is the polished surface. Let me mark the polished surface. Polished. Polished surface. Let's indicate the polished surface. So the upper part will be the polished surface. So the bottom part will be the unpolished surface. So we have to mark it. So this is how we mark it. Okay. This is how we mark it. Now, so the upper part is the polished surface and the downward is the unpolished part. Now, let's draw the incoming light. Let's draw the incoming light. So the source of light is the sun. So it comes from the sun. So let's draw this one. So this is the incoming light. This is the incoming light, incoming, incoming light. So what happens to this light? This light falls down on this polished surface, and then after striking the polished surface, this is most probably a mirror. So after falling on the polished surface, what will happen? The light will bounce back. Okay, the light will bounce back. So this is the bounced back light. This is the bounce back light. So this light, okay, after striking the mirror, it is bounced back. So this phenomenon is known as reflection of light. Reflection of light is simply the phenomenon of bouncing back of light when light hits any polished surface. I hope that's clear. Okay, to make it more interesting, I have here a table tennis ball. So what I will do is that I will throw this table tennis ball towards this whiteboard, and let's observe what happens. Okay, so here we go. 1, 2, go. All right, I nearly let this fall. Okay, so you have seen what I did. I threw the table tennis ball towards this whiteboard. So what happened to this table tennis ball? Did it get stuck at the whiteboard? Did it get stuck at the whiteboard? No, it's not. Of course, no. What happened? It left my hand because I threw it towards the whiteboard. It left my hand and then it went and it hit the whiteboard. And after hitting the whiteboard, did it come back to me or not? Did it come back or not? It came back, isn't it? So this is what we call bouncing. All right, bouncing. Okay, bouncing means Okay, returning back. Okay, bouncing means returning back. Okay, the other meaning of the word bounce is returning back. So when you drop a football on the floor, it will bounce back to you again. Okay, so remember, in the same way like this table tennis ball, light also bounces back. But when do light bounce back? Light bounces back when light hits a polished surface. The best bouncing effect of light we will see when it is done on a smooth polished surface. Okay, so remember, mirrors are better for studying reflection. Understood? Why? Because they have got a smooth polished surface. All right, so remember, the best reflection you will get from smooth polished surfaces. Rough surfaces like walls. Okay, the room where I'm recording now has got walls. These walls are not smooth, so they give bad reflection. But this whiteboard is smooth, so it does give a good reflection. And if I bring a mirror here, then it will give us the best reflection. So remember, smooth surfaces, they give us better reflection than rough uneven surfaces. Okay, so remember that. Now let's erase this and let's study in detail more about reflection. Let's study the two laws of reflection. Okay, there are two laws of reflection. So let's write down the laws of reflection. I hope you are following, my dear students. These lessons are a revision for you. Okay, so I believe that you are able to understand. You have learned about these topics in class 7. I know, because I teach class 7 also. So I know that you learned about these topics in class 7. So it should be easy to understand. So let's go to the next topic, which is laws of reflection. LAWS, laws of reflection. How many laws of reflection did I say there was? Yes, how many? Good. 2, isn't it? There are 2 laws of reflection. So there are 2 laws of reflection, and the laws are very simple and very easy. The first one, the first law. Okay, the first law says that the angle of incidence is equal to the angle of reflection. Let's first write it down. The angle of incidence is equal to the angle of reflection. This is the first law of reflection. The angle of incidence is equal to the angle of reflection. Now let's draw a proper diagram. So let's draw one very important diagram. Let's just draw in the middle. Okay, so let this be the polished surface. So this is how we indicate the unpolished part. So this is the polished surface. Now let us draw the incoming light from the sun. So let's draw the incoming light. So let's say this is the incoming light. Okay, this is the incoming light. Is it straight? Okay, so this is the incoming light. Now class, this incoming light from the sun, remember this comes from the sun. Okay, the incoming light from the sun has got a name. The name of this ray of light which comes from the sun to the surface is called the incident ray. So this is the incident ray. Okay, should I write in capital? Yes, let's write in small. Incident ray. This is called the incident ray. All right, so this is the incident ray. Please make the diagram along with me. Okay, this is very important. This diagram will help you understand reflection. So this diagram is very important. So this is the incident ray. Now the incident ray comes down and it strikes the polished surface at this point. This point becomes very important, so let's make it big. The name of this point is called the point of incidence. Okay, so this has got a name. This is called the point of incidence. I hope it's visible. Okay, this is I, the point of incidence, which is actually the landing spot of the incident ray. So the incident ray lands at this point it is also the point of contact between the surface and the incident ray. Yes or no? Then after this, what we do is we will be drawing an imaginary line which is perpendicular to the surface. So we will be drawing an imaginary line perpendicular to the surface. Remember, we will start drawing the perpendicular line from this point. Okay, so from this point you will draw. So from here you have to draw an imaginary line perpendicular to the surface. So it should be done like this. So this is the imaginary line which is drawn perpendicular to the surface. It is perpendicular. Okay, see, it is perpendicular 90 degree. So this dotted line which I have drawn, which is imaginary, since it is imaginarily, not imaginarily, since this is imaginary, sorry, okay, since this is imaginary, I have drawn using a dotted line and not a regular line. Okay, so this imaginary line which is drawn perpendicular to the surface, since it is perpendicular, the angle which it makes with the surface is 90 degree, is called normal. So it's written n. Okay, and n is for normal. N for normal. It is represented with the letter n, and this is normal. Okay, then after this we will be drawing the reflected ray. Okay, the ray comes down, strikes the surface, and then it will reflect back. Okay, so now time to draw the reflected ray. So let's draw the reflected ray. So the reflected ray will go somewhat like this. So this is the reflected ray. Okay, so this is the reflected ray. REFLECTET, reflected ray. This is the reflected ray. Now observe carefully. If I ask you what is the origin of the reflected ray, then what will be your answer? The origin of the reflected ray will be, yes, correct, very good, will be the point, this point. Okay, it will be this point. Now observe this carefully, class. This incident ray comes down from the sun, okay, and then it strikes the surface at this point. Okay, so till this much, from here till this much is called the incident ray. After landing here, okay, now what will happen? It changes its direction. Now this same ray of light becomes the reflected ray. Okay, previously it came down from the sun. Okay, we can say it came down from the sun down to earth. Okay, then after landing on the surface, from the point of incidence, now it has changed its direction. Now it is leaving the earth and it's going back to the space. We can say like that. Okay, so this is the reflected ray which is leaving the surface and it's heading, okay, upwards. Okay, so this is the reflected ray. Now be very careful here. Be very careful here now. With respect to the normal, we will be studying two angles. One is called the angle of incidence and the other is called the angle of reflection. But where are we going to draw? Will we be drawing here? Will we be drawing here? Will we be drawing here? Or will we be drawing here? So where are we going to draw? Remember, class, that angles, okay, will always be drawn with respect to normal. We have drawn this normal. For what purpose? We have drawn this normal to study the angles. So remember, we will be using the normal. So the angles will be drawn here. So we are talking about this angle. Now what will be the name of this angle? This is the incident ray and this is the normal. So the angle, okay, the incident ray is the angle formed between the, okay, normal and the incident angle, sorry, the angle of incidence. This will become the angle of incidence. So angle I. Okay, this becomes the angle of incidence. So angle of incidence is the angle between the incident ray and the normal. All right, then the other angle will be this angle. This becomes the angle of reflection. So this angle is formed between the reflected ray and the normal. So this angle is called the angle of reflection, whereas this angle which is formed between the incident ray and the normal is called the angle of incidence. Are we clear? Okay, so the first law of reflection says that the angle of incidence, which is this angle, is equal to the angle of reflection, which is this angle. That means these two angles are equal. Basically, it means that if the angle of incidence is 45, if this is 45 degree, then the reflected ray will also make 45 degree. Okay, that's what the law tells us about. If the angle of incidence is 45 degree, then the angle of reflection will also be 45 degree. That is what the statement means. The angle of incidence is equal to the angle of reflection. Very simple law. Okay, it's very simple law. Next one, point number 2, the second law. Let me write down here. So the second law states that the incident ray, the reflected ray, and the normal to the point of incidence, they all lie in the same plane. So let's write down the statement first. So the incident ray, comma, the reflected ray, comma, the normal to the point of incidence, comma, they all lie on the same plane. Let me write in capital because I want to emphasize on this word. So the second law of reflection states that the incident ray, the reflected ray, and the normal to the point of incidence, they all lie on the same plane. We can write here n. Okay, and the normal to the point of incidence, they all lie on the same plane. Now, if at all there is, between the two laws, if at all there is a law which is difficult to understand, will be the second law. So this is the law which students find a little bit difficult to understand. Why? Because one reason is because of this word plane. So what is a plane? Okay, so what actually is this plane? Let me tell you what a plane is. So a plane, my dear students, is any flat surface. This whiteboard is a plane. The floor on which I am standing is a plane. Okay, the mobile screen from where you're watching right now is a plane. The back of the mobile is a plane. Okay, so plane means any flat surface. The ceiling is a plane. The door is a plane. The notebook on which you're writing is a plane. So any flat surface is called a plane. So now let's understand the second law. The second law says that the incident ray, which is this, the reflected ray, which is this, and the normal, again the normal to the point of incidence, which is this. This is the normal, and then we are talking about this normal to the point of incidence, means we are talking about this point. So the incident ray, the reflected ray, and the normal to the point of incidence, they all lie in the same plane. They all lie on the same plane. What is the meaning of this? Let me try to demonstrate this. So for which I have brought some sticks here. So let me take the help of the sticks. So these are what do I say? Chopped bamboos. Okay, these are small sticks which I have gathered because I feel like this will be easier to understand if I do a small demonstration. So the first stick, we will consider this to be the polished surface. Okay, so let this be the mirror. So let's say this is the polished surface. Okay, then now let me show you. So let me now take the this be the normal, because the normal is perpendicular, isn't it? Okay, and then let me take this as the incident ray. So let this be the incident ray, and then the fourth stick, let this be the, let me take this to be the, yes, I think, okay, I think it will be, I hope, okay, I think this is all right. All right, not very practical, but still then I think you can see. So this, okay, let's consider this to be the plane surface. Let us consider this to be the polished surface. Then this is the incident ray. This will be the normal. Okay, this is perpendicular to the, okay, this is perpendicular to the plane. So this is the normal. The middle one, this is the normal, and this will become the reflected ray. Incident ray, normal, and the reflected ray. And what is this? This is the polished surface. Okay. Now the second law says that the incident ray, the reflected ray, the normal to the point of incidence, they all lie on the same plane. What does it mean? Now we know that the plane is a flat surface. So let me show you. So this is an A4 paper. Is this a plane? Yes. This is a plane. So let me show you what the second law means. The second law means this. This one, okay? This is what the second law means. Okay? See, this plane, this white region, okay, which you see, which you agree that this is a plane. Look where I can keep it. I'm keeping it between the incident ray. I'm keeping it touching the reflected ray. I'm keeping it touching the normal. So see, the incident ray, which is this one, the normal and the reflected ray. See, together these three, they all lie on the same plane, isn't it? They all lie on the same plane, nah? Okay, what if I tilt it like this? What if I tilt it like this? Okay, what if I keep it like this? Even if I keep it like this also, you can see that they, okay, these three rays, these three incident ray, normal and the reflected ray, they touch this plane. If I keep it like this also, they touch the plane. This is what the second law means, that the incident ray, the normal and the reflected ray, they lie on the same plane. So I hope you understood. Okay, this is what the second law means. Okay, that these three, they lie on the same plane. All right. Okay, so let's move on. So we are done with the second law. Now let's go and discuss the types of mirror. So did I miss out anything? No. Okay, so that's it. Let's go to the next topic, which is types of mirror. All right. So the next topic will be the types of mirror. Types of mirror. Types of mirrors. Now, there are two types of mirror. One is called the plane mirror, and the other one is called the spherical mirror. Now, in your syllabus, there is like, we are not going to go in detail into plane mirror, but let me just tell you a little bit about plane mirror. Okay, in your syllabus, we are strictly studying spherical mirrors, concave and convex mirror. So, like, we'll be discussing more about that. But remember that there are two types of mirror. So there are two types. Mirrors are of two types. We have number one. We have the plane mirror. And number two, we have the spherical mirrors. So, what is a plane mirror? What is a plane mirror? Let me give you the definition of what a plane mirror is. So, a plane mirror is a plane mirror is a flat, polished surface which produces a virtual and erect image of the object. Image of the object. This is the definition of a plane mirror. A plane mirror, it is the same mirror which you have at home, where you look at yourself before you go to school or before you go out of the home, okay, to see how you look. So we look at the plane mirror. Now it is flat. Go and touch the mirror which you have at home. It will be flat. Okay, it is flat. It is polished. Yes or no? It's a mirror, so it is definitely polished. Then what type of image does it produce? It produces a virtual and an erect image of the object. When you stand in front of the mirror, how do you see yourself? Do you see yourself as you are, or do you see yourself inverted? No, you see yourself as you are, which means you are standing erect. This is an erect position of me. So if there's a mirror placed in front of me, the image, my image on the mirror will be exactly as I am, is not. I'm standing upright, so my image will also be upright. Okay, so a plane mirror is a flat polished surface which produces a virtual and erect image of the object. Remember, there are two types of images. We have got real images and virtual images. We'll be discussing about it later, maybe in the next video. But there are two types of images, virtual and real. Now, remember, all virtual images are erect. So if it is virtual, then it will be erect. If you see an erect image of yourself, that means it is a virtual image. Real images are inverted. So remember, it's virtual, so it will be erect. So when you look yourself into the mirror, you are seeing a virtual image of you. Okay, and since it is virtual, you will see yourself erect. I hope you got it. Okay, now what is important for you is the image characteristics of a plane mirror. So this is the definition which will be helpful for you to remember. Then important for exam is the image characteristics of a plane mirror. So let's write down the image characteristics of a plane mirror. Image characteristics. So what are the image characteristics of a plane mirror? So the image characteristics of a plane mirror are: number one, it is virtual. The image is virtual. We will get a virtual image. Number two, you will get an erect image. Number three, size of the object and the size of the image will be same. Okay, so let's write like this: size of image equal, okay, to size of the object. So if I take this marker and imagine that this whiteboard is a mirror, then okay, the image will also be of the same size as the marker. It's not that in the image I'll get this big image. No, I'll be getting the same image. The size of the image will be proportional to the size of the object. Okay, now not only the size but even the distance also. Even the distance will be same. Image distance will be equal to the object distance. That means if I bring it like this, here the distance between the whiteboard and the object is very less. So even in the image, it will be like this. If I take it far away, then this adjustment will be done in the image also. So in a plane mirror, if you stay nearby, okay, your image will be the distance between you and the mirror, okay, and the image in the mirror will also be same. Then if you go away, then again you have increased your distance, is it not? So even in the image, that correction will be done. Okay, so image distance and object distance is always same in plane mirror. Okay, so number 4, image distance equal to object distance. So this is what is important for you. Okay, so this is important. Remember this one. This is what comes in exam for you. The image characteristics of a plane mirror. Now that leaves us with spherical mirrors. There are two types of spherical mirrors. So if I ask you how many types of mirror are there, the answer is there are two types of mirrors. Name them: plane mirrors and spherical mirrors. Now next question is, how many types of spherical mirrors are there? There are two types of spherical mirrors. What are those? We have concave and convex. So the two types of spherical mirrors are, we have concave mirror, and the other one is convex mirror. All right, so let's discuss in detail about these two types of spherical mirrors. So let's talk about the two types of spherical mirrors. Let's write the topic as spherical mirrors. So there are two types of spherical mirrors. We have number one, concave mirror, and number two, we have convex mirror. Convex mirrors. So these are the two types of spherical mirrors. Now, what is a concave mirror? Let's define them one by one. So concave mirror. Let's define a concave mirror. So how do we define a concave mirror? A concave mirror is a mirror whose reflecting surface is curved inwards. Okay, so a concave mirror is a mirror whose reflecting surface is curved inwards. So a mirror whose reflecting side is curved inwards. What does it mean? Let's draw a diagram. So let me draw like this. Now, a mirror whose reflecting side is curved inwards. Now, if I ask you so I have drawn a figure here, and I want you to tell me, okay, which part is curved inwards? Part or side A or side B? Which side is curved inwards? Side A or side B? Tell me. Is side A curved inwards or side B curved inwards? What do you pick? A or B? How many for A? And how many for B? Yes. Which side is curved inwards? Side A? Are you telling me that this part is curved inwards? Or are you telling me that this part is curved inwards? Alright, okay. So what is the correct answer? The correct answer is side A. Okay, side A is curved inwards. So remember, curve inwards. So this is the curve part. See, okay, this is what it means. Okay, curve inwards means we're talking about this part. Okay, then this is curved outwards. Okay, so this part let's make it the back side, because we are talking about concave mirror. In concave mirror, the curved part should be inside. So this is my left hand, and suppose that this part, okay, this part, not this part, but this smooth part, if I do it like this, then the smooth part, okay, the smooth part is curved inwards or outwards? The smooth part is curved inwards or outwards? It is curved inwards, is it not? So this will be a concave mirror, okay, where the smooth part is curved inwards. So this can be used as an illustration for concave mirror. Okay, remember this. So this is concave mirror. Okay, so the reflecting side is inside. So the inside part is the reflecting side. Let's go to the second one. Let's go to convex mirror now. So what is a convex mirror? A mirror whose reflecting side is curved, it will be outwards, is it not? So the definition is a mirror whose reflecting side is curved outwards. So a concave mirror is a mirror whose reflecting side is curved outwards. Let's draw a diagram. So let me draw here. So now I will draw like this. Now curve outwards, okay, curve outwards. So curve outwards. So if I ask you side A or side B, Which one do you pick? Side A is curved outwards or side B is curved outwards? What is your answer, class? Yes, side A is curved outwards, isn't it? So side A is curved outwards. So it's not side B. Side A is curved outwards. So let me use my hand again. Okay. Now see. How do I do it? Yes. So imagine that this part is the reflecting side now. Okay. Previously I have used this part. Now I'm changing that. I am saying that this part is the reflecting side. So remember, the back side of my hand is a reflecting side. Now if I do like this, then which part is curved? The reflecting side or the non-reflecting side? It's the reflecting side which is curved, isn't it? Okay, so because I told you that this side is the reflecting side. Okay, so the reflecting side is curved. So this is how a convex mirror is. On a convex mirror, the reflecting side is curved. Okay, so this is the curved part. So we are talking about this one. Okay, these are the curved reflecting side. So these are the reflecting side. The reflecting side, it is curved. So that makes this side as the non-reflecting side. So we will draw this to show that it is the non-reflecting side. So see the two types of the mirrors. This is a concave mirror whose reflecting side is curved inwards. This is a convex mirror whose reflecting side is curved outwards. All right. So make sure that you have copied down this, and we will go and discuss now some important terminologies which are associated with mirrors. Now that is a very, very important topic. So let's discuss some important terminologies which are associated with mirrors. Now, we will be discussing some very important terminologies which are associated with mirrors. Let's first write down. So, important terminologies, associated with mirrors. The first one will be pole. So number one, pole. P-O-L-E, pole. So what is the pole? The pole, my dear students, it is the center of the mirror. Okay, so let me draw. Well, let's draw the two types of mirror. So we'll draw here the concave mirror and we'll draw here the convex mirror. Now, so this is the mirror. Okay, wait, let me draw a little better one. So let me draw the concave mirror like this, and let me draw the convex mirror like this. Okay, this will be better. So the pole will be the, see, the mirror is from here till here. Okay, so the center of the mirror is called the pole. So I'll be marking the pole here. All right, remember class, the center of the mirror is called the pole. So the mirror is from here till here. So this is, so the center will be here. Similarly for convex mirror, the mirror is from here to here. So the center will be somewhere here. So the center of the mirror will mark it as pole. So this becomes the pole. This is the pole. Okay. So pole is represented by P. So I better write P, not P-O-L-E here. I'll just use a symbolic representation. Pole I have written here. What will be the definition? The center of the mirror. Okay. So remember it, it's the center of the mirror. Now, next point. The next will be the principal axis. So what is the principal axis? The principal axis, my dear students, it is the line which passes through the pole. Right? So a line which passes through the pole. Through the pole. So this will be the principal axis, and then this will be the principal axis for the convex mirror. Remember, this one, the above one is a concave mirror, and the below one is a convex mirror. Can I write it here? I hope it's visible in the screen. So the principal axis, this is the principal axis. It is a line which passes through the pole. This is the principal axis. It is a line which passes through the pole. All right. Next one, number 3. The third terminology is the center of curvature. So center of curvature. Center of curvature. Now, what is the center of curvature? Now, do you see this curved surface, or do you see this curved area? Now, this curved area is part of an imaginary sphere. Okay, so it's part of an imaginary sphere. So we can imagine something like this. Okay, then similarly for this also we can imagine someone like this. Yes or no? So this curved surface is part of an imaginary sphere. Now every sphere has a center. Yes, yes. So the center of the sphere is the center of curvature. So for this sphere, the center will be, let's draw somewhere. So this becomes the center of curvature. For this sphere, the center will be somewhere here. So let's make this one. So this becomes the center of curvature. So the center of curvature, it is the center of the imaginary sphere. Okay. So the center of curvature is, so the definition of center of curvature will be the center of the imaginary sphere. Imaginary sphere. Okay, the center of the imaginary sphere is called the center of curvature. Now the next point is number 4 is radius of curvature. Radius of curvature. So what is this radius of curvature? Radius of curvature, this will be the radius of curvature. The distance, okay, the distance between the pole and the center of curvature. Remember, center of curvature is just a point. It's just a point. It is just a point. Well, if I tell you to draw a circle using your compass, so you'll be inserting your pencil on one end, and you'll be keeping the compass on the paper, and you'll be drawing a circle, is not? So the mark which the compass, the metal tip of the compass makes on the center, or on the page, sorry, on your notebook, will be called the center of the circle which you have drawn. Just like that, that is the center of curvature. Okay, it is the center of the circle. So radius of curvature, it is the distance between the pole and the center of curvature. So the distance between the pole and the center of curvature is called the radius of curvature. This is the radius of curvature, radius, radius of curvature. So it is the distance between the pole and the center of curvature. This is the radius of curvature in both of them. So the distance between the center of curvature and the pole. All right, remember this, that the center of curvature is represented by C. Okay, so we have a letter, it is represented by C. So let me just write capital C here. Center of curvature is represented by C, and radius of curvature is represented by R. So it is represented by R. All right, so this is the radius of curvature, it is represented by R. So this is represented by R. Okay, the distance between the pole and the center of curvature is called the radius of curvature. So for the convex mirror, this is the radius of curvature, and for this concave mirror, this is the radius of curvature. Next, number 5, it will be focus. So what is focus? for class 10, the focus will be the center, okay, the center between the center, or see, the distance between the pole and the center of curvature, it is called the radius of curvature. So for class 10, we can study focus like this. It will be the center of the radius of curvature. So the center of the radius of curvature will be the focus. So the center for this line, it will be somewhere here. So this becomes the focus. Let's go down to this figure. The distance between the pole and the center of curvature is here, which is called the radius of curvature. The middle of this line will be the focus. Okay, so focus will be the, remember, focus is a point. Okay, the focus is a point which is located in between the radius of curvature. Sorry, not in between, but in between. Well, I can say in between pole and focus. Let's just say like that, that focus is a point which lies exactly in between pole and center of curvature. Focus is a point which lies exactly in between pole and center of curvature. Okay, remember that. So focus is a point which lies in between pole and center of curvature. So focus definition will be, focus is a point which lies in between P. Okay, P stands for pole. Okay, it is represented by P. It is represented by, we can also write, it is represented by P. Okay, so a point which lies in between P and, which means P stands for pole, and C. Okay, C stands for center of curvature. So focus is a point which lies between C and P. It will be lying in exact middle, okay, between C and P. I hope that's clear. Next is focal length. So what is focal length? Now, to understand focal length, let's go to F. Remember, focus is a point between P and C. Focal length is the distance between P and F. So the distance between P and F is called your focal length. Okay, the distance between P and F. The distance between P and F is your focal length. Okay, FL. I'm writing FL. So the distance between P and F is called the focal length. The distance between P and F is called the focal length. All right. So remember, the distance between P and F is called focal length. So focal length is the distance between P and F. Most of the students, they get confused between focus and focal length. Remember, focus is just a point, whereas focal length is a line. I want you to be clear with that. Okay, remember, center of curvature is just a point, but radius of curvature is a line. It is actually a distance. So let's be clear here that you have a lens, or you have a mirror here. This is the pole. This is the center of curvature. This is the pole. The distance between the pole and C, the distance, okay, the distance, we are talking about a length here. It's called the radius of curvature, R. I hope that's clear. Then focus. What is focus? Focus is a point which lies exactly between P and C. So this is your focus. So this is just a point. It's just a point. Next comes focal length. What is focal length? Focal length will be a length. It will be a distance. It will be a measurement. It is the length of the line between P and F. That is your focal length. Okay, focal length is the distance between P and F. I hope that's clear. Okay, so the distance between P and F is called focal length. So when we say focal length, we are talking about this and this. Okay, whereas if we say focus, we are talking about this point. We're talking about this point. I hope things are clear. Now here, one important relationship you have to know. It is a relationship between R and F. Okay, so R and F. So there's a formula which you have to know. So let me just write here. So a formula is there between R and F. So R, okay, which is radius of curvature, is equal to twice of focus. Okay, twice of focus. When we say f here, in this formula, remember f here refers to the focal length. Okay, in this formula, r is equal to 2f. The relation between r, see, r is radius of curvature, r is a length, so we have to consider the length of focus, which will be focal length here. So remember, r is radius of curvature, which is the length between P and C, and f here we're considering the focal length. Okay, focal length, it has to be measurement only, so it will be focal length. So we're talking about this one, the distance between P and F. Okay, so r is equal to 2f is a relationship between, it's a formula between radius of curvature and focal length. All right, so this is a relationship we have to know, that radius of curvature is twice of focal length. Okay, so from this formula we come to know that if the radius of curvature is given to you, focus will be half of radius of curvature. We can easily work out. This is the formula with respect to r. So r will be twice of focus. So if focus, if say f value is given to us as 10, okay, if f is 10, that means r will be twice of 10, which is r is equal to how much? 20. So focal length is 10, so radius of curvature will be twice of focal length, which will be 20. Similarly, if radius of curvature is given to you, say, let's say r, if r is equal to 40, then let's use this formula. So r is equal to 2f is the formula. So r is 40, so 2 into f, we have to find f. So 2 goes below 40, we cancel it and we get 20. So f is how much? F is 20. So if radius of curvature is given to you, using the formula, we can mark the focal length. It will be the exact half of the radius of curvature. All right. So let's do one thing here. If radius of curvature is, say, let's say this is 40. If this is 40 here, then tell me what will be the length, or what will be the distance of this focal length. How much will it be? It will be how much? Radius of curvature from here till here is 40. So this much will be how much? It will be, yes, correct. It will be how much? It will be 20. All right. Then let's go down here. If focal length is, say, 30. If focal length is 30, that means from here till here is 30. I want you to tell me from here till here. I want you to give me r. Focal length is, okay, the distance between P and F, which is focal length, is given to you. It is 30. So what will be the distance between P and C? P and C will be how much? It will be, yes, it will be, yes, 60. Okay, it will be 60. So you got it, isn't it? It's this easy. Okay. Then the next point, number 7, it will be aperture. So what is aperture? The aperture is the size of the reflecting surface. So the definition of aperture is the size of the reflecting surface. So let me tell you what aperture is. Let me remove this formula now. So what is aperture? The aperture refers to the size of the reflecting surface. What if I draw two mirrors like this? I'll be drawing concave mirror only. So one of them is like this and the other is like this. This is mirror A and this is mirror B. Now you tell me, this is concave mirror, okay? So it's curved. The reflecting surface is curved inwards. If I ask you this question, which of them has got more reflecting surface, mirror A or mirror B? What is your answer? It's definitely mirror B, is not? Okay, so this is aperture. Aperture refers to the size of the reflecting surface. This mirror A, is small. So look at the available area for available area for reflection. The curved surface, the reflecting surface, is very less here. Now you look at mirror B. Check out the available area for reflection. Okay, the area available for reflection is more here compared to this. So this mirror has got more aperture. So aperture means the size of the reflecting surface. Okay, so mirror B has got more reflecting surface, so mirror B has got more aperture. Mirror A has less reflecting surface, so mirror A has got less aperture. I hope that's clear. So aperture refers to the size of the reflecting surface. All right. So this was the important terms which you need to know. And then now one small topic, nature of mirror, and after that we will end the video. Okay, so I hope you have taken it down. If you have not taken it down, then before I erase it, you pause the video and you copy down. All right, so assuming that you have copied down, let us proceed. This is the first video and it's getting a little lengthy. I thought of cutting it short, but then let's just continue. The last topic which I will discuss will be the nature of the mirror. So let's talk about the nature of the mirror. Nature of the mirrors. So let's talk about the nature of the two types of mirror which we have studied, concave and convex. So side by side we'll discuss. Let's draw concave mirror here and let's draw convex mirror here. Concave mirror, you know, the reflecting surface is curved inside. That means this is the non-reflecting part. Convex mirror, you know, the reflecting surface is curved outside, so that makes this the non-reflecting part. Now, how do we study the nature of the mirrors? In order to study the nature of the mirror, we will send two parallel beams of light towards the mirror. Okay, so let's bring the two parallel beams of light. So making sure that the figure looks good. So let's draw a proper one. All right. So these are the two parallel beams of light. They are parallel with respect to each other. And let me show you the principal axis. Remember, the principal axis passes through the pole. So this becomes a pole. This is a convex mirror. So let me show you the principal axis. So the pole will be somewhere here. Let's make it as a pole. And let's draw the principal axis. And then let's bring the two parallel beams of light for this mirror also. So this is ray number 1. And this will be the second ray, ray number 2. Now, two parallel beams of light. This is the principal axis. Approaching the concave mirror. The ray of light has just touched the mirror here. The ray of light has just touched the mirror here. So what will happen now? Reflection will take place. So reflection will take place. Now after reflection, the rays will go like this. After reflection, the rays will go like this. So this is for concave. This is for concave mirror. We are drawing for concave mirror. So two parallel beams of light, when they touch a concave mirror, after reflection from a concave mirror, what happens to the ray of light? Initially they were traveling parallel, but after reflection they converge. They converge at a point. They converge at focus. Okay, so they converge at focus. So the nature of concave mirror is converging. Why converging? Because after reflection, the two rays, they converge, okay, at a point. After reflection, they come together at a point on focus. So that is why concave mirror are known as converging mirror. So the nature of concave mirror is converging. Okay, converging means coming together. Okay, now let's study about this one. This is for convex mirror. So convex mirror. So what happens to this parallel beam of light when they hit a convex mirror? So after striking the mirror, reflection will take place. So this is the point where they strike the mirror. So reflection will take place. Now, how will reflection take place here? Here, the rays will go like this. The rays will go like this. So we have to trace it back, and then the rest will go like this. So we'll have to trace it back, and then on tracing it back, okay, we will find that, okay, they touch this point, whereas the actual rays, they go like this. So two parallel beams of light, when they strike a convex mirror, what happens with the two parallel beams of light? They diverge. Okay, this is the nature of convex mirror. Okay, this is the nature of convex mirror. They diverge. So convex mirror, the nature is diverging. So this is the nature of convex mirror. Convex mirror nature is diverging, whereas concave mirror nature is converging. I hope it's clear. Look at the two figures. Closely look at the two figures. This is converging. The two rays of light after reflection, they converge together at a point. And here, the two rays of light after reflection, they diverge. They further go away from each other. So the nature is diverging for convex, and the nature is converging for concave. So that's it, my dear students. This is the video. Okay, this is the video on the introduction, as well as in this video we have talked about light, the definition of light, reflection of light. We have then we have talked about the types of mirror. Then we have discussed the important terminologies associated with mirror, and finally we have discussed the nature of mirror.